Hello, my name is Suhas-Kalagotla. So I'm starting this challenge of doing competitive programming for 365 days, every day 1 hour, using C++ language. So for this challenge, I'll be solving questions from codechef. Actually, I have done few problems in codechef and also participated in a couple of contests. So firstly, yeah, I'm logged in and I'm also having 2 star in codechef. Here, a few of the modules have started and which have not finished. So today we'll be doing level up from 1 star to 2 star module. Let's say continue. And I have done all 16 problems in basic programming. Today we'll be solving in time complexity. Actually I have done few even in this module also. 9 of them are already completed. I'll be start doing from today from the rest of the questions. So let's start going changing directory now. Let's start with the first question. Meanwhile, I'll close all these tags before the page loads. Yeah, here is the first question. So the text editor I'm using is Autumn, which is an open source text editor and very minimalistic. So first question, the code of first question is max them in. So I have a habit of naming them with the question codes. And all this code will be available in the GitHub, and I will provide the link to my GitHub repository in the description. So let's start here. First I'll create the basic header files. Actually I have a snippet for this, not specifically for this. I have like it says array, and this is the snippet I have created to read n number of array elements. And you can, I'll show you the snippets and also provide these are the few snippets I am using, like med sort snippet, and this is for reading a string, and this is for reading n number of integers into an array. And I'll provide even this snippet in the description. So let's see what is this question about. JJ has an array A of size n. He can perform the following operations on the array at most k times. Set AI is equals to A of I plus 1, where I is less than or equal to I, 1 is less than or equal to I, which is less than or equal to n minus 1. Set A of I is equals to A of I minus 1, where 2 is less than or equal to I, less than or equal to n. He wants to maximize the value of the minimum element of the array A. Formally, he wants to maximize the value of minimum I lies between 1 to n and A of I. Can you help him do so? So that's the first question. Let's see what the input format is. First line single integer t, the number of test cases, then the test cases follow. The first line of each test case contains 2 integers, 2 n and k, the size of the array A, and the maximum number of operations allowed respectively. The second line of each test case contains n space separated integers. Okay, let's take the input first. We are reading n here, and then for each 10 cases there are 2 values n. Sorry, here we are reading the number of test cases and we are calling the while loop, and here we are reading inside the solve we need n and k variables, and we need to read them n and k. Int a of okay, we are initializing the array and we are also reading the array values. For each test case, output the maximum value of the minimum element of the array A that can be obtained after applying the given operations at most k times. So here are the sample input and outputs. They are given 5, 4, 3, 2, 1 as array elements. So the operation is done for 4 times and the output is 5. the explanation is also given below. For the test case 1, a of 1 array A becomes 5. A of 2 array A becomes 5. A of 3 array A becomes 5. A of 4 array A becomes 5. Okay. And for the test case 2, the values are 8, 2, 3, 9, 6, 10. And the answer is 3. Here is the explanation. We can perform the following operation in the following order. Set A of 2 equal to A of 3. Array A becomes 8, 3, 3, 9, 6, 10. Therefore the answer is 3. Okay, we can, and the test case 3, 4, 3, 4, 3, 5. We can perform the following operations. A of 2 is equals to 3. A of 4 equal to A of 3. Array A becomes 4, 4, 4, 4, 5. Therefore the answer is 4. So basically, not understanding what they are saying, and the main agenda of this challenge is me learning in the process also. So let me try to understand the question first. Set A of I is equal to A of I plus 1 and A of I equal to A of I minus 1, where T is less than equal to 2. He wants to maximize the value of min of A of I. Okay, he wants to maximize the value of minimum of A of I. So okay, here one time. You need to perform the operation one time. We can perform the following operation in the following order: A of 2. Therefore the answer is 3. The given array is 8, 2, 3, and he got is 8, 3, 3. So he's changing the second element or first indexed element to 3, which is the maximum of both of them. Okay, why didn't he start from A of 1? You can start from A of 1. Okay, that's what he's doing. He's starting from A of 1, so that's why the first index element is, this is actually 0 indexed, because in an array the indexing starts from 0, 1, 2, 3, 4, 5. Okay, even in this he's doing the same. Okay, fine. So basically the question is that we need to compare with the adjacent element, and if the adjacent element is greater than the selected element, we need to assign the adjacent element value to the great maximum of both of them. So that's what he's doing basically. We can see here he took this element, he compared it with 3, it's greater than 5, so he changed it to 5. Same done here. So this thing is done for k times, and he is returning that most A of I, which is nothing but A of 5, which is 5. Okay, here he is starting from A of 2, he's assigning it to A of 3. Here it took from A of 2 and went back to A of 1. Here it started from A of 2 and went to A of 3. Why didn't he go back? A of 2 is equal to A of 1. Why didn't he apply this operation here? You can perform the following operation on the array at most k times. Set A of I equal to A of I plus 1, where I is less than or equal to 1 is less than or equal to I, less than or equal to n, which is n minus 1. Set A of I equal to A of I minus 1, where 2 is less than or equal to I, less than or equal to n. Hmm. Okay, let's do first a of 2, I mean this operation, set a of I equal to I plus 1. He's saying that he wants to maximize the min of a of I, where I is between. So what is the minimum number in all these arrays, which is 1? So he wants to maximize the 1, and the minimum of all of this is 3, and he wants to maximize the 3. If he wants to maximize for 3, he need to assign to 8, right? But he assigned it to the adjacent number, which is also 3. And the minimum number here is 3, and he maximized it to 4, because the number of options are allowed are, for test case 3, allowed are 2. And here it's like 1000, you can do the 1000 times, so 5. So for this test case, if you cannot perform the operation more than the number of elements that are allowed, then obviously, and the element will be the answer will be the maximum element. So let's create a variable called answer and assign it to 0, and let's find the maximum element. So int max is equals to the minimum, the most minimum we can, since all the values lies between 1 to 10 power 9, so 0 will be the minimum, and we'll take a for loop, and then we'll compare it with the maximum element. If max is less than a of I, then max is equals to a of I. If any element is greater than the maximum element, then we will be saying that element is the maximum element. So we got our maximum element. If k is greater than number of elements, then we will print the maximum value. Okay, now else, if k is not the maximum value, then we'll go for the while loop, k minus minus, because we can do the operation for k number of times only, and we'll take the element at position 2. Before taking the element, we need to save it. So my idea is like, we need to compare the element in position 2 and position 3, then we need to increment. So we'll take for loop. Well, the time complexity is not ideal here. If you want to do set I plus 1, set a of I equal to a of I plus 1. So I starts from 1, and then it ends to n minus 1, and I plus plus. By the way, speaking of time complexity, and the time complexity is order of n square, because we have a loop inside another loop. So if a of I is less than, right, okay, if a of I is less than a of I plus 1, then we will assign, that's what he's saying, right, a of I, we are setting a of I to a of I plus 1 for these cases, and for these cases. Okay, a of I equal equal to a of I plus 1. That's it, I guess. Now let's print the loop. Let's print our array, sorry. Int I equal to 0, I less than n, I plus plus. Sorry, C out. Printf is in C, right? So in C++ it is C out. A of I, and we'll also give some space. Let's compile. Let's run, and the input we will be giving is like 4 5 space 4 5 4 3 2 1. Wow, that's unexpected. Are we reading properly? Yeah, reading is done properly. 5 3 2 7 6 7. Let's try printing what we are reading. Four, 5 4 5 4 3 2 1. Yeah, we are reading it properly because you can see 5 4 3 2 1 is print, and still we are in the code. That means some loop is not ending. We found the maximum element. Let's print the maximum element also. See, these kind of errors are hard to find because you will not get any compilation error, but when you are executing it, you are not getting the desired outputs. 4 3 2 1. And the maximum element is 5. It's computed properly. So the error is in this part of the code. Okay, if k is greater than n, give n number of times. Next, else, well, k minus minus. K of I equal to. Instead of taking a loop here, I got an idea. The idea is, since they are saying you can use it k number of times, right? That means I cannot increase more than k, isn't it? Because if we start from a of 2, it will be 1 time, a of 3 is 2 times. So I mean to say is here, like, let's say k is 4. So here you can see that I is not increasing 4. Okay, it reached 5. That means 4 plus 1. If he's going for this set. This seems pretty hard. Okay, let's check the submissions, what they have done. View all submissions. So this is what I actually do. If I can't solve a problem, I'll spend some good amount of time in trying to solve it, but I couldn't get the answer. The reasons may be that I may be lacking some concept that I need to So here what is he doing? He's reading n and k and reading the elements. After reading the elements, he's sorting the array, and after sorting the array, he's just printing the minimum of k comma k comma n minus 1. He's printing the element in the array with k comma n minus 1. Is maximize. Okay, if you saw, okay, let's go to the question back. Let's understand the solution. Okay, let's sort this. We'll get 1 2 3 4 5. It's 5 4 3 2 1. We'll get 1 2 3 4 5. After getting 1 2 3 4 5, k is 4, n is 5. Minimum of 5 and 4 is 4. So if let's say 1 2 3 4 5 0 1 2 3 4, so here we have 4, so answer is 5. Okay, it does work. And next we have 8 2 3 9 6 10. So solving 8 2 3 9 6 10. If we sort it out, we'll get 2 3 6 8 9 and 10. And he gave 1, right? So 0 and 1. So this is the element that's getting printed. But what is actually happening? What is the operation is doing here? He is just swapping the numbers and is saying maximize the value of the minimum element of the array A. Formally, he wants to maximize the value of minimum element. So we'll not consider the first element, right? So minimum element from these things is 2. So if he's maximizing it, he should get 4. Okay, it's equal to n. Okay, he's sorting. We can use both of the either the function which is like built-in function, the sort function which is used in the solution. By the way, shout out to him. He's Deepesh. Sorry if I butchered the name wrong. So he's printing the minimum of k of n minus 1 from the array. That's what he's doing. You can use the built-in function sort, or you can use the function which you can sorting any function which you can do yourself. I'll show you how I use my merge sort function. So msort is the key, and if I plus tab, here is my function which I have already written in my snippets. So I'm using that function here, and this is not the proper logic. We need not even find the maximum element also. After reading the elements, we'll sort them out. So msort will take 3 values. First value is the array, and then it takes the lowest number, then the highest number, and also the middle. Which is n by 2. Sorry, that is the merge function. We are calling the merge sort function. We need to give, that's what I was wondering, why do we need to give the middle? So msort, we have sorted the array, and then we are printing the element which is the min is also another function, or you can just use an if loop. If else statement like this. Variant k, okay, k we have used. Let's z is equals to if a is greater than It's not done in this way. It's just a is greater than, it's not a, it is n. K is greater than n minus 1. Then if it is greater, if it is true, if k is true, then we'll take k itself, else we'll take n minus 1. So min, we not use min also, we can set z. Okay, let's check this. G++ max the min. Okay, msort was not declared in the scope. We have declared it. Okay, it's not msort, it's the merge_sort function we are calling. Msort is the keyword I used. Sorry for that. Call my merge_sort. And okay, let's compile now. G++ max the min. Now we are running the code. Let's give the input 4 5 4 5 4 3 2 1, and the answer we got is 5. Very good. And I just realized the code didn't end because the number of test cases we gave are 4, so we need to give all the 4 test cases. Let's copy all this, Ctrl C and Ctrl Shift V, and those are that's the answer we got. 127980826. This is wrong. Let's check test case 1 and 6 and n value 6 and k value is 1. 8 2 3 9 6 10, and the answer we got is 10, but we need to get 3. Okay, maybe my way of computing the minimum is wrong. If k is greater, we are giving it k. That's my bad. If k is greater, n is smaller, so the answer should be smaller, not the greater. That's the mistake we have done. Now let's compile it. Let's copy all the test cases and let's place it. We are getting 5245. For the second one, we are facing a problem. Okay, let's see. Let's check the code. It's 6 1 for one test case, 6 1 8 2 3 9 6 10. Okay, we are getting answer 3. What was the mistake here? Copy, paste. Okay, that is weird. If we run in single test case, we are getting answer as 3. If we are giving all the inputs at a single time, we are getting it as 2. Why is that? Let's say 2 test cases, 5 4 5 4 3 2 1. Okay, we got our first answer 5, which is correct. 6 1 8 2 3 9 6 10 3. It is working. There's something wrong with. Okay, now let's paste our answer here. Then first we'll run it. We'll see what happens for the test cases here. Okay, we are getting 5245. That's bad. Okay, we are actually calculating the minimum. If k is greater, we are saying it's n minus 1. If it is true, then the value z will have n minus 1 value. Are we supposed to calculate the minimum of n minus 1? Yes, we are supposed to. Okay, let's just use the sort function here for now. maybe my merge sort function is wrong. It's a sort array comma array plus n. And when we compile, okay, it's just bad me that passing the test cases, say 1 6 1 8 2 3 9 6 10. It does work properly for a single test case, and for giving all the inputs at a time, it even works properly. So what's wrong with my merge sort? Let's just print all the values. Let's say for int I equal to 0, I less than n, I plus plus, cout a of I, and let's have the n. Okay, let's just have spaces, then we'll print out a new line. Let's clear, let's compile, let's run. Now let's take all the values, let's print them all. We found the mistake here. We are reading some, okay, we are not reading the complete value actually. So what is happening? First input, then the array. Okay, this is the input we are giving. Till this is the input. So first array sorted is like this, and the answer is 5. Second array sorted is like this. So there is a mistake in it's a garbage value, I guess. Let's run it. Yeah, this value is different, and this value is different. That means it's the garbage value. Why are we taking the garbage value? Why are we not reading 8? Okay, we are actually reading it. 2 3 6 8 9. 2 3 6 8 9. We are not reading the 10 value. What is happening to 10 value? Is our merge sort wrong? I guess we need to give the size of the array, not the index of the array. Let's check with, okay. When we give the size of the array, now we are facing the same problem in all the questions. So it's not. What is L? L is index itself, it's not the size. Here it's an edge case, like we are only facing this problem only here. Oh no, we have been stuck here for the past 49 minutes, for past 50 minutes. That's very bad, very very bad. Why are we having the problem only for that thing? For only that test case we are reading 5.4. Okay, let's print before itself. Okay, we said 5 and 4, n has 5 and 4, so size of that is a of n. So we'll read from 0 to n. For 0, 1 2 3 4, and less than 1 for 5. We'll take the a of 5 values. Okay, for now let's use the only sort function, and I'll check what's wrong with my code, and I'll update you later with this code. So for now, let's remove all this code, and also my code which I written for to test what's wrong with me. So let's compile it, let's run it, let's take all the inputs. Yeah, it all does work. Let's copy it and then paste. Let's run. So from this question, what did we learn to solve? What is the thing I am liking to solve in this question? We need to check that thing. We need to learn this thing, and that's how we actually progress, right? So since it's my day one, it didn't go really well. Let's submit it. Actually, he's trying to maximize the minimum element of the array. Maximize the minimum of value of minimum of a of I. So from first index to nth index, he's checking what is the minimum element, and he's trying to maximize it by using these operations. Currently running 13 test cases. It's a correct. Of course, it's a correct answer because we just copied it. So, thank you, Deepesh. Okay, let's move on to another question. And by the way, I solved all these questions myself. I didn't copy them. Maybe most of them. So let's remove this. Okay, now let's solve. Let's solve. Okay, we didn't check how hard this question is actually. The rating for this question is solved. Where do we find the rating? It says solve. Okay, fine. We are not able to see the rating for this question. Anyways, let's solve this question. So autumn per maxis dot cpp. Batson gives an array of n integers, so it's an array question again. So let's take our predefined snippet, and now he wants Sherlock to recognize the array in a way such that no adjacent numbers differ by more than 1. Formula: if recognize the array in, then the condition that should be less than or equal to 1 for all I lying from 1 to n, where denotes the absolute value of x, modulus of x denotes the absolute value of x, should be met. Sherlock is not sure that a solution exists, so he asks us, and we will be helping Sherlock by using C++ language. Okay, we handle the input actually, test cases, read, and we are calling the solve function for those many test cases and reading the n and also the array elements. We need to print yes or no. I guess this is pretty easy because you'll be going and you'll be finding the differences between adjacent numbers. So let's take an flag equal to 0. So initially let's say if 0, then see out. Okay, I guess you need to specifically print yes or no. Okay, slash n is also, you can use endl or self. Okay, here we are saying initially we are saying f equal to 0. That means this is always false. So we'll be saying like, you give me any array, and I'll say no because f is 0, because we haven't written our logic actually. So let's write our logic. The logic to change f to 0, that means it will say yes. I guess the reverse is easier, where if we say for everything it is 1, and if it's equal to 1, if it equal to, yeah, I guess this is easier. Let's say for everything equal to 1, then we'll write logic, then we will end up saying it's not true, we'll say it's false. That is easy. Instead of proving true, proving false is easier for this type of question. So we need to traverse the array. So let's take a loop. Now after traversing, if a of I minus, okay, let's say I plus 1, a of I, should we sort the elements? Because if a of, like, for the here 3 is greater, 2 is not smaller, so if we do so if we do 3 I plus 1, in a sense we'll get 2 here. 2 minus 3, it is minus 1. So if we sort the elements, everything will be adjacent to each other. Is it mandatory that no, it's like I'm thinking like position is mandatory. Like let's take the other 3 to 4 5, because now it should be no, and if we sort it we'll get 3 4 5. Now it is yes. So actually position is mandatory, so you shouldn't sort for this. So let's not sort. Then how do we do this? Okay, we have ABS is a function which gives the absolute value without any signs. So if the absolute value is equals to 1, then we'll say nothing, right? If it is not equal to, then we'll be facing the problem. We'll say f equal to 0 and we'll break the loop. We need not iterate for the rest of the elements. I guess that's it. We are doing it from, yeah, that's it, I guess. So let's compile and take our inputs, and we got no and no. For these we got no. Okay, actually we need to get yes. Why did we get no? We got no. That means this else path is being executed for some value. So let's go here. Let's say one test case and 4 size of that is 4 3 2 2 and 3. Okay, let's say if equal to 1, should we say like continue, something like that? No, right? It doesn't matter actually. If it is equal to 1, there is nothing to execute, so we'll start from the first. Let's actually say, let's do something. Let's ask us to print the value. I didn't compile, forgot to compile, sorry. Every time you make changes you need to compile. Okay, let's take only one test case. Let's say one test case 4 3 2 2 3. Okay, for first execution itself we are getting -1. We are using ABS, right, for absolute value. Okay, fine. Then let's just say it can be 1 or -1. Let's copy this, sorry, let's copy that, and let's say or -1. Now the problem is handled. Now we shouldn't get any. Now we need to get our desired output. Let's not forget to compile. 1 4 3 2 2 3. Wow, we are still getting. let's say C out a of I value and a of I minus 1 value, sorry, plus 1 value. Let's do the reverse because we are doing now we also want we'll get our subtraction value also, right? Enter for new line. For some reason my keyboard got stuck there. Let's close this terminal. In here, yeah, it's working. So let's compile. I guess we need to wrap it up because it's been 1 hour. Let's solve this and then we'll wrap it up. Yeah, 3 2 2 3 1 4 3 2 2 3 2 3 and we got no. Let's use gets here. Still we are getting 2 3, which is no. What is wrong? Let's just say else if a of I minus a of I plus 1, even in that equal to 0, equal to 1. Let's use brackets here. Maybe actually it doesn't matter because first you'll subtract, then you will check the condition. Now let's run. Let's say 1 4 3 space 2 space 2 space 3. Still getting the wrong answer. Couldn't find what is going wrong here. If the difference between two adjacent elements is, the element should be less than or equal to 1 modulus. It is actually absolute function, right? Okay, C or C++, it doesn't matter, it's absolute function. See, it actually absolute of -1 is 1, but it's already positive or 0, it will return the number as it is. For example, a of 1 1. It is the absolute function. We are picking up the first element. We are starting from equal to 0. If absolute of a of I minus a of I plus 1 equal to 1, then do nothing. Initially we are saying f equal to 1, means every time it need to print f is equals to 1, C out, yes, but it's somehow entering into this loop. Now let's compile. Let's run. And what are the inputs we need to give? 1 4 3 space 2 space 2 is 3, and the answer is still no. Not understanding. No need to recognize, no possible way. The explanation. Sorry, no need to reorganize. Sorry, did I miss something? Why did reorganize come? Okay, it's not recognize, it's reorganize. I'm so sorry. Reorganize the array is then the condition that absolute value should be met. Okay, okay, it's reorganized. Anyways, I'm saying the whole question in wrong point of view. So 4, 3, 2, 1 is the function. Okay, let's say 1 and 2. We can reorganize it 1, 2, 3, 4. But every time making it, as we have seen, 4, 3, 1, 2 is the first array. Okay, let's take the inputs. Like, you can reorganize, but you need to find whether there exists a way to reorganize. So how do you do this? Okay, let's remove this thing. It's not the adjacent elements, actually. You need to check. Okay, there is something more in this. My bad, I have just read the question wrong, and also couldn't solve the in the wrong way also. What we need to do is we need to check. How do you check it actually? Well, I'm thinking is, if you sort the array and if you take the middle element and add the elements which are left to it, all the smaller elements to it and all the greater elements to it, and subtract them both. Okay, it's like weight balance, and the difference should be 1 or -1. That's what I'm thinking. But let's say the elements are like 8, 12, 6, 53, 9. So here the element is 6. So we'll add all the elements to it's left. What about the element 6? Okay, let's do one thing. We'll add this number, then we'll subtract this number. Then we'll add this number, then we'll subtract this number, then we'll add this. So at the end of the day, it should be having 1 or 0, right? Because if he is given 3, we'll add 3 to some variable. Let's directly take it. Let's say sum equal to 0 for int I equal to 0, I less than 1, n I plus plus. So let's to do that, if I is an even number, then we'll add it to sum. We'll add a of I, sorry. Else we'll subtract it from sum. Okay, and let's remove this logic, and let's remove that comment also. Let's just say, okay, we need those things. Let's just say if sum equal to 1 or sum equal to -1, let's just say in simple terms abs of sum equal to 1, then we'll print this, else we'll print no. So that's how you do it. Well, after compiling, running, I'm still getting no. Because if you add 3, then we'll subtract 2, answer is 1. Then you'll add 2 to it, right? Then 3, then subtract 3 from 3, answer is 0. So if you get 0, okay, if sum is equals to 1 or sum equal to 0, let's just say we are having the array 1, 3, 4, 5. So we'll add 1, they will subtract 3, then we'll be having -2. Then we'll add 4, now we have 2, then we'll subtract 5. So it doesn't work. If let's just make this thing to 2, 2 is added, then we'll get -1, then we'll get -1 plus 4, 3, right? 2 minus 3 equal to -1, 4. Now we are adding -1 plus 4 will be equal to 3. Now 3 minus 5 will get minus 2, right? So we'll make this to then we'll make sum to 0. If it is minus 1, we'll make it to 0. So then 0 plus 4 will be having 4 here. Now 4 minus 5. Okay, what I'm saying is we'll add 2 more conditions. If sum equal to 0 equal to minus 1, then let's make sum as 0. If sum equal to 0, we know if equal to 1, then we'll convert it to 0. Okay, if it's not either minus 1 or 1, now for example 2 3 4 5, 2 minus 3 equal to minus 1, so we'll convert it to 0. Oh, let's just take 1 here. So 1 minus 3, it is equals to minus 2. So we'll not convert it into 0, and then eventually we'll end up getting some other value. But the question is, what if there is a chance of rearranging this thing such that it does work? Like, just say we have 4 here and 3 here, and we have 2 here. So now 2 minus 4 is equal to 2 minus 4 equal to, okay, we need to just sort the array, that's it, because sorting gives all the adjacent elements. I'm thinking all some nonsense stuff. Let's just sort the array. After sorting the array, let's apply the code I have done. Let's just sort. After sorting, what do we do after sorting? I guess this is it. Let's copy, paste. Yes, no, finally it does work. The thing I'm doing is it's too complicated. I made it complicated by I'm sorting it, and then I am adding if it's even. I need not do this, I guess. I can just say the thing before I have done f, and let's say f is always 1, and let's say if a of I plus 1, the lower since we sorted I plus 1 is always greater equal to 1, then do nothing else, f equal to 0 and break. Let's compile, run 2 4 3 2 2 3. Wow, we still got no. We got no. Wow. I guess we are back to square one again. We are okay, it's been long. A long time. 1 4 3 2 2 3. Okay, I forgot to I did compile it. I wanted to print the values. Why are the values not why the values are not printing? Compile it one more time. 1 4 3 3 2. 3 2 2 3. It says no. Because if you sort will be 2 2 3 3, right? So it can be 0 also, or minus a of I equal to 0. So it can be 0 also. Even if it's 0, do nothing. 1 4 3 2 3. Just not working. Let's go back to the code, the long logic I have wrote, and I guess I can simplify it. This is it, right? So let's take this code. Let's see what is happening with the test cases they have given. Will this logic works? Then let's go ahead and let's check our logic with someone who has done it already. It's wrong answer. Since I have spent enough time on it, let's check the answer written by Hitesh. Sorry, not meant to open that. I want to see the code. So he's sorting it and he's getting the absolute value. If it is greater than 1, he's printing no. Okay, this is a lot more cleaner. And here my approach is, he also has his observation. So the array has, when array is sorted, minimum difference elements are always at alternative positions. Then you can simply check if the difference is more than 1 or not. If I is greater than or equal to n minus 1, see out yes. Okay, he wrote everything inside. Okay, what is this? Okay, he defined I outside the for loop, right? So he can get access to it. There is some edge case I'm missing in my code. What is it? Actually, a comma a plus n. After sorting, we'll check what's happening here. This is say f equal to 0, and let's check the difference between elements. He is using absolute, by the way. So let's say if absolute difference between array of I plus 1 and minus array of I, if it is happening, yeah, we shouldn't do anything, right? Okay, it should be always true. Okay, we shouldn't do anything. If it is not happening, then immediately we should say 0, and then we need to break. That's what I was trying to do from beginning, but for some reason it's not working. 1 4, let's say 3 3, okay, 2 2 3, it says no. Okay, let's try saving this in some other variable. Okay, I forgot. AB should be, it should be greater than 1. He says 1, the difference should be greater than 1. Why should it be greater than 1? Okay, it's for no, right? It shouldn't be greater than 1. It should be less than or equal to 1, right? Because here we are saying if it is true, if it is greater than done, then it enters into this, and then it says break. So now let's compile it. Let's run it. 1 4 3 2 2 3. It still says no, it's not working in this way. Have we taken the values correct? I mean the input correct? Yes, I guess the input is correct. Let's check one more solution. What is the other style of doing this? Submissions. Even he has done the same thing. Rajiv, let's check Rajiv's code. And he says it's greater than 1, then count equal to 0, break, else count equal to 1. If count equal to 1, see out yes, else see out no. I really want to find the solution for this code. Answer for my what am I doing wrong? Why couldn't I find the difference between two adjacent numbers? Let's remove all this. Let's just say cout. Let's just take int diff equal to, diff is short for difference, is equals to a of I plus 1 minus a of I, right? Now we'll print the difference. Let's compile. Let's take an input 3 2 2 3. So first the difference is 0, next the difference is 1, next the difference is 0. And what is this? What is this obscure number? For I of 0, let's just print our array we are reading. Cout. Three two two 3, yeah, which is correct. Now we are getting correct answer. It says yes. Oh, sorry. Because f is always 1, it always says yes. What is this 0? 0 is because of this for loop, I guess. 0 1 0 1 0 1 0 some random garbage value. Yeah, one more time I got the random garbage value. I'm not understanding why am I getting that value. Okay, here I am saying I plus 1. I shouldn't do that. Let's I minus 1 and let's say I plus 1 and let's start from 1. Now it works. Now it works. Now it should work. 1 4 3 2 2 3 minus 1 and some random big value. This is I shouldn't go beyond my limits. Yeah. Okay, now if this difference is equal to 0 or absolute of this difference is equal to 1, do nothing else. F equal to 0, then break. Now let's check. Copy our values. and it says yes and no, and it probably should get submitted too. While it's compiling, I forgot to mention a point. I'm using bit/std++ as the header file, which includes all the necessary header files and all the functions needed for the competitive program, and our answer is also got selected. So successfully we have done, on the first day we have done one question by ourselves and one question with a guidance. Of course we actually took guidance for this, but as you have seen, we actually solved it. But my only mistake was going out of the range by making I+1, which is generating a garbage value, and finally a wrong answer. So the thing is, actually we learned how to check the mistakes, right? At least from today's session, and it's been a long first video. Firstly intended to it have for only for 1 minute, 1 hour, sorry, not minute, but it extended to this point. That's how competitive coding works, I guess. You will spend a lot of time. Anyways, thank you.